Hello, in the last video we discussed about DCC, their preparation, application and synthesis. Yes, and also mainly we discussed the application of the DCC in amide preparation. Well, so in this video we are going to learn about the second reagent molecule, that is DDQ. So DDQ here, dichloro dicyano benzoquinone molecule. Yes. So we can see in here the structure of the DDQ molecule. It is a chloro-cyano substituted benzoquinone molecule, and the number that shows the position of that substituent on a benzoquinone molecule. Yes. Quinone, that is a cyclic ketone. Well, so DDQ here is a chemical reagent with a molecular formula C6Cl2Cn twice O2 molecule. Yes, you can see in the structure also. So DDQ is a oxidizing reagent. So that means oxidizing reagent means the addition of oxygen or the elimination of hydrogen takes place. That is the oxidation process. So mainly the DDQ that we used as a dehydrogenating reagent. So dehydrogenation is nothing but the elimination of hydrogen molecule. So that we all know. So particularly, so this DDQ that we used as a dehydrogenating reagent in a cyclic alkane, alcohol, phenol and steroid ketones. Yes. So in that particular molecule, so DDQ we used as a dehydrogenating molecule or for the dehydrogenation process. Then DDQ is a very reactive and may be used in where the substance is difficult to dehydrogenation. So its meaning is, in particular molecule, if it is difficult to dehydrogenation, means if it is difficult to eliminate that hydrogen molecule, in that particular molecule we used DDQ as a dehydrogenating reagent. Yes. Then DDQ is used under anhydrous condition. So anhydrous means the absence of water. Yes, because it is decomposed in presence of water. That means DDQ easily react with water that form the hydrogen cyanide. So we all know hydrogen cyanide is a poisonous compound. So that we avoid the water molecule to react with the DDQ. And the reaction can be carried out in inert solvent like benzene, toluene, THF, that is tetrahydropurone. Yes, that is a solvent molecule. Then, so these are the properties of the DDQ molecule. The next is mechanism of dehydrogenation. So DDQ that we used as a dehydrogenation process, so that mechanism we are going to see now. Then the main important is the DDQ that eliminate or abstract the allylic hydrogen atom. So allylic hydrogen is nothing but the hydrogen that is bonded to allylic carbon atom. Then the question is, which carbon atom we call the allylic carbon atom? The carbon neighboring to the double bonded molecule. The carbon that is neighboring to double bond molecule, that we call allylic carbon atom. Then the hydrogen that present on that carbon atom we call the allylic hydrogen. So this DDQ molecule that abstract that hydrogen as a hydride ion. Yes, so we can see in here the mechanism. This is DDQ that abstract hydride ion. Hydride means it is a H minus ion. Yes, this abstract hydride ion, then this molecule, that is the DDQ molecule, they get resonance. So that gives a positively charged carbon atom on a allylic carbon atom. Then the phenolate ion. So this we call the phenolate molecule or phenolate ion. That is because of the hydride ion transfer from the allylic carbon atom to DDQ. Yes. So next is this DDQ molecule further that react with this charged molecule, that is a cyclohexadiene. So this phenolate ion that abstract this hydrogen as a H plus. So if it eliminate the hydrogen as a H plus from this molecule, so it become the C minus. So that minus charge or that electron, this carbon atom, that said to this carbon atom, so that we can see in the next structure. So after eliminating this H as a H plus, this bonded electron that said with this carbon atom, so that is a benzene molecule. So this is the process of dehydrogenation. So here initially we not have the double bond molecule. So after the elimination of H2 by the DDQ, so we get here what? The double bond in between these two carbon atoms. So this process also we called aromatization. Initially this is cyclohexadiene. It is not an aromatic molecule, but benzene is a aromatic molecule. So it's one of the application of DDQ is aromatization of the cyclic molecule. So this process is the mechanism of dehydrogenation. Okay, next is the preparation of DDQ. So here first DDQ is synthesized by the scientist Thale and Janther. Yes. So the scientists Thale and Janther, the first they prepared the DDQ molecule. So a reactant molecule used is the quinone. This quinone molecule, after reacting with hydrogen cyanide, that is the two molecule of hydrogen cyanide in presence of the ethanol medium. So quinone, after reacting with hydrogen cyanide, it gives the 2,3-dicyanohydroquinone. Yes, quinone that convert into hydroquinone by the substitution of two cyanide molecule. This hydroquinone, after oxidation, it gives the quinone molecule, that is the 2,3-dicyanoquinone molecule. This dicyano substituted quinone molecule after reacting with the HCl. So actually I reduced one steps here. So this hydroquinone after reacting with HCl molecule, this for a monochloro substituted hydroquinone. This monochloro substituted hydroquinone after oxidation, that gives the monochloro substituted quinone molecule. Yes, so that quinone molecule, that is a monochloro substituted quinone molecule, after reacting with second molecule of HCl, then that gives the dichloro substituted quinone molecule. So I just reduce one steps. I written directly this cyano substituted quinone molecule after reacting with two molecule of HCl, so that gives the dichloro substituted hydroquinone. So this dicyano-dichloro substituted hydroquinone after oxidation, so it gives the desired compound, that is the DDQ. So this is the process of synthesis of DDQ. So actually this DDQ is first synthesized by the scientist Thale and Janther. Yes, quinone, the two molecule of HCl, it gives the dicyano substituted hydroquinone. This hydroquinone after oxidation, that gives dicyano-substituted quinone molecule. The oxidation process is the elimination of 2 hydrogen molecule. Then this quinone molecule, after reacting with 2 molecule of HCl, that gives the chloro-substituted hydroquinone. This after oxidation, that gives the DDQ. So this is the synthesis of DDQ. So I think you clear this concept. Next is the application of DDQ. So one of the application that we had in our syllabus, that is aromatization of tetraline molecule, that is a tetrahydronaphthalene compound. Yes. So DDQ is an effective reagent for the dehydrogenation of hydroaromatic compounds. So for example, so particularly this tetraline, they convert into naphthalene just by boiling the tetraline with DDQ in a benzene medium. So that is the process of conversion of a tetraline into a naphthalene in practically. Yes, so that mechanism we are going to learn in this, that is the aromatization of tetraline. So tetraline also we called, it is a fused ring molecule that we can see in here. The next is, that is the mechanism of the conversion of, that is tetraline into a naphthalene, that we are going to see now. Yes, the DDQ that we all know, so it abstract hydride ion particularly from allylic carbon atom. Yes, that allylic carbon atom we just represent that is in a cyclic molecule. Here this carbon atom we called, it is a benzylic carbon atom. Yes, allylic or benzylic carbon atom. So the DDQ that abstract that hydrogen from a particularly benzylic carbon atom. So that is a carbon atom that is attached to benzene molecule, that is called the benzylic carbon atom. Then this DDQ that abstract a hydride ion, after abstracting hydride ion, that DDQ convert into phenolate ion, then this carbon atom convert into C+. So that we can see in this structure. Then at this position, the carbon atom that is neighboring to this carbocation, then that shared a bonding electron that is present between C and H. Then after sharing this bonding electron with this carbocation, this hydrogen that eliminate as H+. So that H+ reacting with this phenolate ion, so that convert into a double bond in between these two carbon atoms. That indirectly means the one DDQ that abstract 2 hydrogen atom, so that convert one of the, or that form the one of the double bond. So that process we call dehydrogenation. Tetraline DDQ, so it abstract hydride ion from benzylic carbon atom. So that benzylic carbon atom that gets the positive charge because it eliminate H- ion, or that remove, or the DDQ that abstract H- ion, that convert into phenolate ion. That phenolate ion second, next it taken, or it takes the H+ ion from the neighboring carbon atom, so that results the formation of the double bond in a tetraline molecule. So overall, the DDQ that convert into hydroquinone and the tetraline that become, or that form one double bond by the elimination of 2 hydrogen molecule. So in the next step, the second molecule of the DDQ that again abstract the one of the benzylic hydride ion, so that is carbon atom nearer to double bond or neighboring to double bond, that we call the benzylic carbon atom. The DDQ that abstract hydride ion, then you can see here it convert into a C plus. So that is C plus is because so that loses its one of the bonding electron. Then this DDQ that for phenolate ion. This phenolate ion, next it abstract the hydrogen atom, means that is a H plus ion from this molecule. So that results the formation of the double bond between these two carbon atoms. So that means initially DDQ that abstract hydride ion, that hydride ion, after the elimination of that hydride ion, this carbon atom become a C plus. Then the DDQ convert into phenolate ion. This phenolate ion next that abstract the proton from this molecule, that is the carbon atom neighboring to carbocation that loses its hydrogen as a H plus by the effect of this phenolate ion. So that results the formation of double bond between these two carbon atoms. Then this molecule convert into an hydroquinone, that is cyano chloro substituted hydroquinone and the naphthalene molecule. So this is the total process of aromatization of tetraline into a naphthalene. So tetraline, after reacting with two molecules of DDQ, so two molecules, the results the elimination of the two molecule of hydrogen atom, means the total 4 hydrogen atom from the tetraline molecule, that results the formation of 2 double bond. So that convert a tetraline into naphthalene, that means non-aromatic compound into an aromatic. So that total process we call it is the aromatization of tetraline into naphthalene. So I think this clear the concept of one of the application, that is the aromatization of the tetraline molecule by the help of DDQ. So that is by the dehydrogenation process. The second application is the oxidation of benzylic and allylic group. So we all know the benzylic and allylic group, that is carbon atom aside or neighboring to the C double bond C. Allylic we represent that is an acyclic alkane. Benzylic that we represent in a cyclic alkane molecule. So here oxidation process that we call the elimination of hydrogen, the addition of oxygen. Yes. So in this particular oxidation process, the addition of oxygen that takes place to the benzylic and allylic carbon atom. So here we can see the DDQ that oxidize benzylic or allylic alkyl group into a carbonyl group. So these two carbon atom that we call the benzylic carbon atom. So this after oxidation that convert the carbon into a carbonyl groups. So here we can see in this changes between these two molecule, the addition of oxygen that takes place in a tetraline molecule. Yes, so that tetraline become convert into a carbonyl substituted tetraline molecule. Yes, this is the tetraline. So this tetraline after oxidation that convert benzylic, one of the benzylic carbon into a carbonyl group. So this process we call the oxidation. So benzylic oxidation by DDQ in aqueous acetic acid that proceeds via an intermediate benzylic acetate, so which is hydrolyzed under the reaction condition. Means so in converting or in the process of oxidation from tetraline into an carbonyl group, so that proceed via an intermediate benzylic acetate. So that we know the molecule of benzylic acetate. So that benzylic acetate after hydrolysis that convert into the carbonyl group. So this is the second application of the DDQ, that is the oxidation of a benzylic or allylic group. So here tetraline after oxidation with DDQ in aqueous acetic acid that convert the one of the benzylic carbon atom into an carbonyl. So this is the process of oxidation. So these are the two application of the DDQ molecule. So thank you.